All right, so we're going to find the area of any regular polygon. Pentagon, hexagon, decagon, dodecagon, doesn't matter how many sides. As long as it's regular, we're going to be able to find the area of it. Okay? First of all, regular. Hook me up here. What did regular mean back in the day? Still means today. 20. Here we go. Radika, what did regular mean back in the day?
All sides, all interior angles, and all exterior angles are congruent.
Perfect definition. There you go. All the sides are equal. All the interior angles and all the exterior angles are equal. I do want to introduce a new piece of a regular polygon. Everyone see how I started at the center and started drawing these dashed lines to every vertice? If that was in a circle, what would we call it?
Radius.
Radii, right? That's what they're called. Even though I put them in a polygon, that segment from the center to a vertice is still called a radius. Even though it's not in a circle. Still called a radius, everyone. And you'll see it. I'm just going to use the hexagon example right now. You'll see I have 6 triangles. And what do you know about all the radii? They're congruent. So I've formed what type of triangles here? Isosceles, yeah. And let's keep even digging deeper. Yes, they're isosceles, and all 6 are what to each other? Congruent. There you go. So what type of triangles have we formed? Congruent isosceles triangles. So instead of telling you how we're going to find the area of all these figures, how do you think we're going to find it? Let me turn it over to you now. I just created 6 congruent triangles in that hexagon. How do you think I could find the area, even though I don't know the area formula for a hexagon? Is there a way I could still find the area of that hexagon without knowing the official hexagon formula? What's up, Audrey?
Find the area of all those triangles.
Well, do I have to find the area of all of them?
Or just one. And then
Just one and do what?
Add or multiply.
Multiply it by 6, since they're all the same. Everyone agree? So that's what we're going to do. Pretty easy. I'm not going to give you more formulas to memorize. You're going to figure out, all right, based on the figure, how many congruent triangles can I make? So area of a regular polygon, number of triangles, times, what's the area of one of them again? 1/2. Base times height. Make sense? That's what we're going to do. How many triangles can be formed times the area of one of them? That'll give me the area of the full figure. All right, can we talk real quick before I get into an actual example about base and height? So I'm just going to take one of these triangles right here in my hexagon. Go back to my first diagram in the hexagon. Any of those 3 sides could be the base. All right, any of those 3 sides. So I'm just going to call this one the base, which means I'm going to draw the height to it. So watch what happens, and we're going to talk about what happens when I draw the height in. What do we know about the height drawn to the base? It's what? Perpendicular. Here we go. So it's perpendicular. Now, I don't know if you notice, but in this triangle, I've created 2 congruent separate triangles. And I ask you this because these 2 angles up here now are going to be congruent. All right, that top angle just got bisected. And what you're going to notice today, you're going to find the degree measures for me, and they're going to be some pretty familiar degree measures that we're used to working with. All right, when we actually find how many degrees are in those angles. Because I already have a right angle and a right triangle, so anybody want to try to guess what type of triangles we're going to come back and work with today? Right triangles, more specifically. Atticus?
60, 30, 90.
There you go. And maybe, what's the other type? Yeah, probably. Okay, so we got to be on the lookout for those. All right, so just a little background before we find our first area. So first one, I got an equilateral triangle up there. One radius is 4. Can you find the area in simplest radical form? You can still use 1/2 base times height on the full triangle. You can. All right. Getting to there, though, is a little bit tough when you're given the radius. So that's why I'm going to suggest, can you guys draw in another radius, please, that makes a triangle? So I'm just going to draw in this radius right here, which I also know is 4. How many of those triangles can I fit in there? How many congruent triangles can I make in that diagram? If I draw in all the radii. Let's go 2, 5. Sabrina, how many congruent triangles can I make?
3.
3, right? I draw in the other radii, everybody see all 3. So to find the area of this triangle, I can take those 3 times one of the areas, 1/2 base times height. So that's what my plan is right now. So let me get rid of that so it's not confusing. All right, see if you guys can help me out. Here's my base. Go ahead, draw in your height. Perpendicular. Actually, hold on. Before we draw in the height, I got to make a question to you guys. Could anybody help me find what that angle is right there? Can I get your help? How can I find that angle measure? Because I'm about to bisect it with my height. That's why I'm asking you. I'm about to bisect that angle with my height. So what's that angle right there that I just made formed by the 2 radii? And I don't know if this helps if I draw in the other radii. All 3 of those angles are congruent right there. All 3 of these bad boys are congruent. I don't know if that helps. Atticus?
120.
How'd you get it?
Both the other angles are 30 because they're being bisected and they're all 60 because it's an equilateral triangle.
Good. All right. Let me step back and go step by step for what you just said. Atticus is like, hey, this full triangle is equilateral. I know in any equilateral triangle, each angle is 60. The radius bisects it. So I have 30, 30 here. And then how many degrees are left? Yes, 120. Is there anywhere else I could have got? Quincy?
You could just say it's 360 degrees.
Yep.
It's like full circle.
I have a full circle here when I add up these 3 interior angles. So I could have also said, hey, take 360 divided by 3. I get 120. That's the other way. Okay? So let me get rid of all this stuff here. All right, so now we've established that that angle is 120. It's about to be bisected. When I draw in the height, now what's the angle on each side? What's the deal?
I was just thinking 180 divided by 3.
Why 180? 180 is a straight line. We're going all the way around. Take a look.
Oh,
Angle. Oh, now I have. Three angles. 1, 2, 3.
sorry, I was thinking because the internal would be measures of the triangle.
These angles at the vertices, yes, are add up to 180. Okay? All right, moving on. Drawing the height. 120 gets bisected. What's it become? 60. Oh, there it is. 30, 60, 90. Again, base is right here. And here's the height I'm going to plug into my formula. I'm only doing the base and height of one of those 3 triangles. All right, you guys are turning it over to you. Where's the 4 across from? Is that the shorter, longer hypotenuse? Shorter, longer hypotenuse. Anthony, what do you got? What's the 4?
4 is the
Hypotenuse. Thank you very much. Let's review the rules real quick. The longer leg is shorter leg times radical 3. And the hypotenuse is 2 times shorter leg. So Anthony just said the hypotenuse is 4. What's the shorter leg then? Shorter leg would be? Hypotenuse is 4. Go backwards. What's your shorter leg? 20. Radika, what's my shorter leg?
2.
2. Good. And that's also my height. 3 times 1/2. We'll get the base in a second. Times 2 for my height. What's across from the 60 then? What's my longer leg then? Longer leg? 11. Anthony, back to you. What's my longer leg?
2 radical 2.
Watch your mouth.
2 radical 3.
There you go. 2 radical 3. Better. Oh! Is that the base of the triangle I'm trying to find the area for? Is 2 radical 3 the base of the triangle I'm trying to find the area for? Is 2 radical 3 the full base of the triangle I'm trying to find the area? No, it's not, is it? It's not. I'm not going to plug 2 radical 3 in for B. That's 2 radical 3. What about the other side? Also 2 radical 3. Because remember, these triangles are congruent. CPCTC says those segments are equal. So if one side's 2 radical 3, the other side's 2 radical 3. How big's the base? Add them up. Oh boy, he's adding radicals. You haven't seen anything. That side becomes 4 radical 3. There it is.
I have a question.
Yep.
You know, couldn't you just like, okay, so you know how there's like a radius at the top? And
Yep.
then there's like, can you just do 6 times 4 radical, like 1/2 6 times 4 radical 3, because that's the height of the triangle?
Yeah. Yeah, that you're using the big triangle and doing base times height on the big one. Yeah. Yep, instead of dividing up. That's fine. Other questions? All right, so simplest radical form. The only radical I see in there is 3, so I'll keep the radical 3 and you can multiply everything else. And I don't think there was any units. One way, take a regular polygon, divide it up into congruent triangles, find how many triangles there are, and multiply it by the area of one of them. Or if anybody just heard what Omni just said, she said, hey, let's just use the big triangle. The base of the big triangle would still be 4 radical 3, but now your height would be, you got, what did we have, 2 and 4, so times 6 for your height. That would be for the big triangle instead. Fine, fine. Anything you want to talk about before we go hexagon? All right, let's go hexagon. How many triangles can be formed here? How many congruent triangles can be formed in a hexagon? And you guys know what the pattern is, but just asking. Ryan, how many?
6.
6, yep. So the way I'm going to approach it is I'm going to take 6 triangles, find the area of one of them, 1/2 BH. And that one of them's already drawn in. Oh, you're welcome. Where can I use the 3 for? Where can I use the 3?
Base.
Base, yeah. That's the base of one of the triangles I'm trying to find here. So 1/2 times 3. Hey, we just got to find BD, the height. That's all we need to find. How long is BD? All right, let's get to it somehow. Let's get to it. What's happening to the 3? What's happening to AC when I draw the height in? We talked last problem. What's happening to AC right now after I just drew in that height? Let's go top. Vinny, what's happening to that 3?
It's getting bisected.
Okay, so what's AD and DC?
1 point.
There you go, 1.5. So I know this is 1.5. Again, I need to know what that height is so I can plug it into the formula. Oh boy, anybody? Can you find any angle measurements for me? So I can see if it's a special triangle or not. Let's start with angle ABC. Angle ABC, what is it? Angle ABC, can you find out how many degrees are at ABC? 7 spot. Go, Sinjin, how many degrees?
The 60 degrees in like the main part of the triangle.
Yep, so angle ABC, you could say 360 now divided by 6, that's 60. And we've been talking all class, that angle gets bisected. So angle ABD, this one right here, half of it, 30. So everyone see I'm working with the 30-60. Just the 30 and the 60 are in different spots. All right, could somebody help me find the height now? Can you help me find the height? One eight. Owen, help me find the height.
The height's 1.5 radical 3.
Good. What Owen is doing, he's taking shorter leg times radical 3. So 1.5 was the shorter leg times radical 3. Good job, Owen. Thank you. Two different ways I want your answer here. Simplest radical form first. So everyone put the radical 3 in your answer. 6 times a half.
I didn't mean to leave, but I'm all set.
Where are you? All right, you're all set?
Yep.
Okay, submitted.
All right.
Did you submit it?
Yes.
Okay, I'll grade it later. Thanks, Sam.
Yep.
All right, bye.
Bye.
All right, that was fun, huh? Sorry, kids. And what did that one end up being? 13 and a half units, meters squared. And then round to the nearest 10. So now 13 and a half radical 3 rounded to the nearest 10. Go right ahead. What are we looking at? 23.4? There we go. Questions, comments? How we feel about this? Now, if you don't want to use this method, I think you have to use this method with something like a hexagon. But if you just have an equilateral triangle, you don't need to use this method. You can use just plain 1/2 base times height. And as we get into the last problem, which is a square, all right, the radius is 7 centimeters. Can we find the area of this square? So you have choices. You can divide it up into 4 triangles if you want, or you could just use the good old square formula, which is base times height. So if you find a side, multiply it by itself, you got the area. A lot of different ways here, which is why I'm just going to let you guys go and investigate on your own. You guys in class, if you want to talk to people around you about their ideas and how they did it, that's fine. I know you guys don't have that option at home. I'm sorry, but if you guys here want to turn around to somebody next to you, behind you, feel free, talk it over with them. Because this could get nuts. And there are no rounding directions for a reason. No simplest radical form, no nearest 10th, not needed here. Whole number answer. Whole number answer. I'm just curious on how many different ways we're going to come up with to solve this.
Do the radii bisect the angles of any polygon?
Yes.
Nice.
Mhm. Yep. All radii are congruent. They will bisect the angles. I don't know if anybody's approaching it this way. Sometimes kids get silly. Hey, if you're drawing a height from that center down, then it looks like the 7 centimeters is your height. Remember, 7 is the radius, everyone. 7's the radius, because when you draw the height in, as you can see on my diagram, looks like the 7 belongs to the height. Does not. Come on, dig deep. And first period came up with an even different way than cutting it up into 4 triangles or just using the square formula. We found a third way to do it. Instead of making 4 triangles, make 2. Make 2.
Is that something you to do with any?
Square, yeah. Because square is all the sides are equal, that's why you can get away with it. Right triangles, anyway. How's everyone doing here? The best way to approach this, huh? Call on somebody, ask for volunteers for methods, hear every method. Like that. I'm ready. Ready to go? Anybody want to throw a method at me here that you're pretty confident in? Hi, Quincy.
You could multiply the diagonals together because it's a rhombus.
So you're saying drawing another diagonal,
Yeah.
which is 7, right? Drawing the other diagonal, since it's a square, diagonals have to be equal, right? And then you're saying, all right, well, a square is a rhombus, so why can't I use the rhombus formula, which is 1/2 d1 d2, 1/2 14 times 14, right?
Yep.
And that comes out to be 98.
Yeah.
Method number 1. Sophia, hi.
Probably the one just the basic one out there, the one you did a couple times before. You can split it into a 45. To make it into a 45.
So you want me to make 4 triangles
Yes.
when I draw in all the radii? You're finding the area of one of them, right?
Mhm.
Okay, so this, yep. So what okay, here's my question. Did you just leave this as a 45, 45, 90, or did you draw the height down to make a 45, 45, 90?
Well, I didn't. What I did was I found one of the sides because I drew the height down and made it 45.
Okay.
There.
So you got 45 here.
Yeah.
So this would have been 7 divided by radical 2?
Yeah.
Yep.
So that was like 3.5 radical 2, and I doubled that here one side and just multiplied that by itself.
All right, so if you did the 4 triangle method, you got 4 triangles times one of them is 1/2 7 over radical 2 plus 7 over radical 2, which I'm not a big fan of leaving, but it comes out to be a whole number, times the height, which is also 7 over radical 2. So if you divide it up into 4 triangles, that's what it ended up being. Yep. What's up, Omni?
So if you draw another radius from the bottom left-hand corner,
Hold on.
it also makes a 45, 45, 90 triangle. And you know both your legs are 7, so you just do it like that.
And then, what'd you say after that?
I just did Python.
Pythag, or if you know your 45, 45, 90 rules, right? It's leg times radical 2, so you could go, oh, that's 7 radical 2. That means every side is 7 radical 2. 7 radical 2 times itself is 98. Yep. This is great. Anything else? Go ahead. Anything else want to throw at me? Good job. It's pretty impressive. Yes,
If
Omni.
you want to do it with two triangles, you can draw another radius from the top left-hand corner, and then you know that like the base of that triangle is 14, and you can draw another radius from the bottom left-hand corner, and that's the height of 7.
Yep, that's what first period threw at me. They said, hey, you've got two right triangles here, 7, 7. You can find that's 14. You draw on this radii, which is 7 centimeters. So now you know one triangle is 1/2 base of 7 drawn to a height of 14, and there's two of them. So that's the other way they went about it. Just so you, in case you guys are this triangle here. That's what we just found the area of. Base right here, height right here. Yep. Pretty impressive. All right, any other questions, comments there? Tonight, all it is square, hexagon, triangle. The problem tomorrow, what if one of these triangles I make doesn't come out to be 30, 60, 45, 45? We're going to have a problem that we got to figure out, all right? Please look at the bottom of your notes. I just want to make sure we're all good here, and I'll give you more specifics. You'll see in parentheses it says leave all your answers in simplest radical form. I'll let you know which two to leave in simplest radical form because there's only two that are possible to do that. Okay, so for tonight's homework, the only two you'll be able to leave in simplest radical form are numbers 2 and 12. Okay, numbers 2 and 12. Everything else just follow the directions. All right, 2 and 12 should be left in simplest radical form tonight. All right? All right, guys, have a good night. See you tomorrow. Be smart, be safe.